Hello. So in this class, we'll do Algebra 2, Chapter 6.2, the natural base E. So E, it is a Euler's number and is approximately equal to 2.71828. It is a irrational number like pi and uh, its decimal digits continue infinitely without repeating. So it is best known for its role in exponential growth and decay, and it acts as a base for natural logarithm ln. We see that as x tends to infinity or as x increases, it approaches as it increases, 1 plus 1 over x raised to power x will reach a value approximately e, which is 2.71828182846. It is a irrational number and it keeps on going. So this is, we can see from this graph that it approaches and then it almost reaches the value of e. So here it is a natural base function. This y is equal to a e raised to power rx. It is called a natural base exponential function with the base natural as e. So in this function, when a is greater than 0 and r is greater than 0, then it is a exponential growth function. As x increases, y increases exponentially. So suppose if we take a function where a is equal to 1 and r is equal to 1, then it becomes y is equal to ex. So if we see when x is 0, then y would be 1, and if x is 1, then y is e. And if we further plot the points, we'll see that as x increases, y also increases exponentially in this. If we want to graph, we can graph like this. So as x increases, y is 1. And when x is 1, y is equal to, this is around 2.7128. So it will be like this. When x is 1, it will be approximately this. So it will be like this. Okay. So this is a exponential growth function. As x increases, y increases exponentially. So as x in this function, when as a is greater than 0, but r is less than 0, then it will be a decay function. As x increases, y will decrease. So suppose in this form, we put this function when a is equal to 1 and it is r is less than 0. Okay. So for this function, we see that as x increases, y will decrease exponentially. So in this function, when x is 0, y is equal to 1. And when x is 1, y will be e raised to power minus 1, which will be 0.368. So the function would be like this. It will decrease as the x increases. So we see here how is the exponential decay function. With when x increases, y decreases exponentially. When x is 0, y is equal to 1 here. And when x is 1, y is 1 over e, which is 0.368. So this is the question 21. Tell whether the function represents exponential growth or decay. So in this case, if we compare this function with y is equal to a e raised to power rx, we see that r is greater than 0 and a is greater than 0, sorry, and r is less than 0, which is negative 0.25. So this will be the exponential decay function. So let's make a table and see the values. So it is an exponential decay, and it is also, we can see that as x increases here, -2, -1, 0, and 1, y is decreasing. It means that it is a exponential decay like this. We can say, and it becomes less and less as the x increases. Okay. Now let's do another problem. So in this case, we see that a is greater than 0 and r is greater than 0. So it is, both are positive, so it is an exponential growth function. So let's make a table of values and see. So in this, we see that as x increases, y is also increasing. So this function will be like this. Okay, so this is a function y, and this is y is equal to 0.6 e raised to power 0.56. Okay, now let's do more problems. So in these questions, we have to use the property of exponents to write the function in the form of y is equal to a1 plus minus r raised to power t, and then we have to find the percentage rate of change. So this is e raised to power negative 0.75. So we see here that a is equal to 1 and r is less than 0. So we can see that it will be a um, exponential decay. However, we can calculate this. So this will be e raised to power negative 0.75 and t. So this gives approximately, this value will be approximately 0.472 raised to power t. Okay. So now if we have to write it in this form, 1 minus r. So we see that 1 minus r is equal to 0.472. Okay. So 1 minus 0.472 is approximately is equal to r. So this will be, r will be 0.528. Okay. So this gives us 1 minus 0.528. This is the r. Like 1 minus r was 0.47. Okay. So this is 0.528. So percentage decrease here, find the percentage rate of change. Because r is less than 0, it was already a decay, and the percentage decay or decrease is 52.8. percent. This is a R in decimals. So this is the percentage decrease. Now let's do one more problem, maybe problem 29. So in this case, we see that A is equal to 2 and R is greater than 0.4. So it is we can see that it will be the exponential growth. Okay. Now to calculate this, we'll do E 0.4. So this will give us 1.492. Okay, we calculate this with the calculator. So we know it is more than so, 1. So this will be growth. So 1 plus R is equal to 1.492. So R is 1.492 minus 1. So it is 0.492. Okay. So we can write here in this form, it is 1 plus 0.492. So we can see that the percentage increase is 49.2%. So this is a exponential growth because R is greater than 0 and percentage increases about 49.2. Let's do more problems. So now we will, so we see, now we learn about continuously compounding interest. So we know the balance of an account which is earning compounding interest is given by this formula, where A is the amount after when the P is the principal, R is the rate of interest in decimals, N is the number of compounding interest, number of compoundings per year, and T is the time in years, and A is the amount which we balance of an amount earning compound interest. Okay. So now when we are when the interest is compounded continuously, then the amount A after T years is given by this formula. And let's see how we get this formula. So we put M is equal to N by R. So the formula becomes like this. We put here M, this and this N. For this N, we write M, R, and T. Now, if we put this as 1 plus 1 by M raised to power M, and we know that this is E. Okay, so we put here E and RT. So this is the formula for the uh, amount in an account after T years when the interest is compounded continuously. P is the principal and R is the annual interest rate in decimals. So let's do some questions and then we'll come to know. So this is the detail, like P is the principal amount, T is time in years, R is the rate of interest in decimals, and N is number of compounding per year. Sorry. Now this is a question like you invest $2,500 in an account. So account 1 pays 6% annual interest compounded quarterly. And account 2 pays 4% annual interest compounded continuously. So which will pay more in 10 years? So for account 1, P is 2500 principal amount. N is 4. Compounded quarterly means number of compounding in a year or per year. Okay. So N is 4 and R we have to write it in decimals. 0.06. Okay. 6% is 0.06. This is rate of interest in decimals. Okay. So now if we put and time is 10. So if we put this in the formula 2500, 1 plus 0.06 by 4 raised to power nt. So 4 into 10, 40. Okay, this is 4. So this gives us around $4,535.05. Okay, now let's do account 2. So here we know the form P is again 2500. It is continuously compounding. R is 0.04 and T is 10. So this gives A is equal to 2500. E formula is A is equal to PERT. Okay, so E and R is 0.04 times 10. So this gives around 3729.56. So we can see that account 1 here gives 4535 means it gives a greater amount than amount 2. So we should choose account 1. Okay, because it gives. Because here the interest rate was more. Here the interest rate was less and the time was same in both. Okay, but here we use continuous compounding. Here we used compounding quarterly, 4 times a year. So we should choose account 1. So we should choose account 1 because it's giving more amount, then account more final amount, then account 2 after 10 years. Okay. So please keep practicing. Please do more problems and feel free to let me know if you need help with any of the questions. And I can send a recording or I can help you out. Okay. Do each problem from the book. Thank you.